Hello, and welcome to a little video about the domain and range of exponential and logarithmic functions. Let's get started. On the right-hand side, you should see a graph of the function -2 log base 3 of x plus 8. First, let's find its domain. Domain is talking about the behavior of the x's, so we're looking at the left to right behavior. So let's see what's happening on the left. On the left-hand side of my graph, it doesn't look like I'm going anywhere past -8, which makes sense because we have an asymptote there. So our most left is -8. I use a parenthesis because I can't equal -8, ever. Okay, now let's take a look at the right-hand side. On the right-hand side, it looks like we're going just to the right. It's not flattening out, it's just continuing to the right endlessly. So, infinity. Okay, now let's take a look at the range. This one we're looking at up and down. So let's see, what is the lowest it goes? Well, we can't really tell, but it looks like it's going all the way down very, very slowly. So that means we are slowly approaching -infinity. Okay, well, let's look at how high does it go? How far up does it go? Well, right here we're going up, and it doesn't look like we're stopping. So our range is from -infinity to +infinity. I know my infinities look like crap. I cannot draw them well. All right. Now, another thing I'd like to think about is this an increasing or decreasing function? The way I figure it out is I put my finger, or I guess highlighter, on the left-hand side, and I trace going to the right. It looks like we're decreasing. All right, let's try another one. Ooh, perfect, exponential. So we see an exponential graph on the right-hand side. F of x equals -2 times 1/2 raised to the power of x plus 3. Let's talk about the domain. Domain is left to right. So let's look on the left-hand side of my graph. On the left, it looks like it's going diagonally, which means it's just continuing to the left without stopping. So that will be -infinity. And when I look to the right-hand side, sure, it's flattening out, but it's continuously going to the right. It's just not going any more up. So, from -infinity to +infinity. Boy, those looked bad. Let's try drawing those again. -infinity, +infinity. Okay. Next, let's take a look at the range. Let's see how far down it goes. So first, down. Well, it looks like it's going all the way down. The arrow is just pointing downwards, and it's continuously decreasing. So the range on the downside begins with -infinity. And then as we go higher up, I notice that we never ever cross the value of 3. Now, if you keep it in mind, our asymptote is at 3. We can never have a number larger than 3, on the y-axis. So they go all the way to 3. Also, let's take a look at this as increasing or decreasing. I start on the left, and my highlighter seems to be going up, so it is increasing. Right, next we have the graph of a logarithm, another one, -log base 3 of x plus 6. All right, let's take a look at its domain, the x's. So how far left and right do they go? All right, so here's the leftmost, here's the rightmost. On the left-hand side, it doesn't look like it's ever crossing 0. It's never crossing 0. Okay, so on the most left, we start with 0. And on the right, it looks like we're slowly just continuing to the right. So, +infinity. Wow, that was awful. Let's zoom in a little. There we go. That's a little better. So bad. Okay, range. Range are our y's. So let's see how far down it goes and then how far up. Okay, so down. This is where it's going downwards, and it looks like it's just slowly getting smaller and smaller. Okay, so negative infinity. Right, let's see where it's going up. Well, it's going up over here, and it looks like it's just going up. So, positive infinity. And let's see, is this an increasing or decreasing graph? I'm going to trace it with my highlighter. Decreasing. All right, one more graph. Here we have f of x equals 2 to the power of x, a very nice exponential function. First, let's take a look at its domain. Domain is left to right. Okay, so on the left, it looks like it's just continuing going to the left. So that's negative infinity. On the right-hand side, it looks like it's going slowly to the right, very slowly, but it's going there, so positive infinity. The range, okay, so let's do down and then up. It's going, I guess you can say it's going down over on this side and up on that side. Okay, it's going down on the left-hand side, but it's never crossing 0. And that's our horizontal asymptote. How convenient. Okay, let's take a look on the upside. When we're going up on this function, we're just going up, forever up. So, positive infinity. Beautiful. And let's see, is this increasing or decreasing? I trace left to right, increasing. Now check this out. I'm going to go ahead and zoom out. All of my exponential functions had a domain of negative infinity to positive infinity. And check out the inverse. Our logarithms instead had their range from negative infinity to positive infinity. That's not a coincidence. Exponentials and logarithms are inverses of each other. So if exponentials have x's being from negative to positive infinity, that means logarithms have their y's being from negative infinity to positive infinity. Also, I'd like to point out how closely related the other values are to the actual equation. Check this out. In this graph for the domain, for the logarithms, this -8 comes from here, from the asymptote. For this other logarithmic one, let's just keep it, this 0 comes from the fact that there's nothing being added inside of the logarithm to the x. And then we look at our exponentials. This 3 comes from the asymptote 3. And, well, there's a 0 asymptote for this one. And in this guy, we're adding 0. 0's our asymptote. Here it is. So lots of relationships between there that I wanted to point out. Yeah. I hope this was helpful for you in understanding domain and range of exponential and logarithmic functions. If you have any questions, please feel free to reach out to me or to whoever your teacher is. Otherwise, have a wonderful rest of whatever day it is for you. Bye!